All right. First, can you confirm whether my audio is clear? Right. Good evening, all. Good evening, and can you confirm whether the all right, it's working, right? Give me 1 second. Okay. Right. I'm loud and clear, right? Okay, we'll start. We'll start. So, good evening again. We are in the day 4 now, day 4 of the S2A discussion series we started, right? So, main focus of this S2A discussion series is getting a touch with the past papers, right? Other than the questions we discuss in the class and the paper classes, right? New questions and model questions we discuss in our classes and paper classes. Main focus here is we are going to touch on the past paper questions mainly, right? And for past few days also we'll be doing different things, different lessons based on the previously covered lessons, right? And today also I'll be doing this as a continuation of the vectors and force equilibrium questions we did last day, right? And I have put the questions that in the sense the questions to the Telegram channel, so you can get it from the Telegram, right? The link is pinned in YouTube live chat, and if you are already in channels, you can find it through the channels as well, WhatsApp channel or Telegram channel, right? So get ready, we'll start. And for the other lessons we are covering in the classes, like ongoing lessons we are covering in the classes also, I'll be allocating S2A discussions as an example for surface tension. Since we have finished now, for surface tension, I'll be allocating a separate S2A session, and for viscosity, my plan is to allocate another session, right, for thermal parts, right? So likewise, for our ongoing lessons also, I'll be allocating S2A sessions to cover up the past papers. Okay. All right then. Then without further ado, let's get into the discussion. Right. So give me 1 second. I'm going to share the screen. Day 4. Right. Okay. Screen is visible, right? So if there's anything, you can put into the chat. Okay, let's start. Screen is visible? Yes. Okay, right. Let's get into the chat. 21. A circular coin of radius r and mass m is placed so that it touches a step. Height capital R shows in the figure. The minimum value of horizontal force F, this should be F, right? F required to pull the coin over the step is, right? So about this type, I discussed in the theory class as well under force moments, right? I discussed in the theory class as well in the force moments, under force moments, right? Same thing. So this is the requirement to be satisfied if you are doing a pull over, if you are going to do a rolling, right? This is what is to be satisfied, right? So let's say these points are A, O, and B, right? A, O, and B. Now, if we are to, one second, right? If we are to pull this, if we are to climb this up over the step, right? It's dual. Thanks. Okay, now it's fine now. Yeah, if you notice it, please remind, because sometimes I forgot to hide that self view. Once the self view is on, you can see both views. That's the thing. Okay, now it's fine. Thanks. Okay, now if this is to climb up the step, it should rotate around, or it should roll around point B, right? It should roll around point B, right? It should roll around point B. Then the requirement to be satisfied is, now it is to, if it is to climb up the step, this is how it should be rolled. Therefore, force moments in that particular direction should be not equal. It should be either greater than or equal the opposite force moment. This is the logic. Force moment to that particular direction, right? Force moment towards that particular direction should be either greater than or minimum condition. As a minimum condition, it should be equal to the opposite one, right? It should be either greater or equal to the opposite one, right? Now let's mark the forces here. From here we know mgx. From here mgx, right? And here there is a reaction. Here there will be a reaction, say RB, and here also there will be a reaction, say RA, and our F is given, right? Now the thing is, when this is climbing up, when this is starting to climb up the step, we know it leaves the surface at 10. Once it leaves the surface, RA becomes 0. Once it leaves the surface, RA becomes 0, right? RA becomes 0. Since we are considering force moments about B, RB is not contributing. Then only two forces are remaining. For clockwise one, only F contributes. Perpendicular distance is from here to here. That is also a radius. That is also a radius into R. Greater than or equal to. Anticlockwise force moment is by mg. Perpendicular distance is from here to here. That is also a radius into R. So these two cancels. It says F is greater than or equal to mg. So minimum value of the force required to do this is mg. Mg answer 3. Right? Mg answer 3. Did we share the live to the channel? Yes, ne? Right. Take it down. Right. Let's move on. 22. A figure F1. A figure F1 to F8 drawn to scale act on a point object or as shown. It is drawn to scale. Right. Part is missing. Result. We are asking the direction of result. That is missing here. Right. Find the direction of resultant. Find the direction of resultant. Right. Now, since we have forces which are acting along the same line, now I'm going to use something like this. Let's say we have two forces acting along the same line like this, as 5 newtons and 3 newtons. So we can say the resultant of this is 2 newtons in this particular direction, right? So I'm going to use this same idea here. I'm going to apply this same idea here. See, I'm going to apply this same idea here. Right. See, now using this, we can simplify these forces which are acting along the same line. No? Now, if I simplify F4 and F8, F4, the magnitude of F4 an equivalent vector to the magnitude of F4 should cancel off and the other part remains. Then the remaining one is like something like this, no? Right? When the part remove, this part should be removed. From here to here, there's a certain length. That certain length should be removed from this, and the other part should remain. Got the point? Likewise, easily we can argue. Then if I keep on doing that, now F4 is no more, F8 is no more. Instead, we have this simplified one. And if I do it for F5 and F1, right? Something like this should remain. Something like this should remain. This is no more. This is no more. And by F6 and F2, right? Something like this will remain. These two are no more, right? By F1 and F3, something like this will remain like this. See now what's remaining? Only these four are remaining. Only these four are remaining. This one, this one, this one, this one. Right. Now, try to break this down to two directions, two perpendicular directions. Try to break this down to two perpendicular directions. Now, if I try to break it down in this particular direction, this direction, we know from this a component is coming. From this also a component is coming. So for sure, a downward component is going to act here, right? And for the horizontal ones, from this a horizontal component is coming, no? And this is also horizontal. From this an opposite one is coming, but yet this one is greater. This one is greater, which means a horizontal in this particular direction remains in the system. A horizontal in a force in that direction remains in the system, right? Then we know resultant should be somewhere in between, right? It should be something in between. And this force is higher, this force is greater, this force is greater, this force is greater. Then it should be closer to this, right? This is greater. So it should be closer to this. Closer to this means from C and D, it should be C. So final answer is OC. Final answer is OC, right? Simple arguments. Now, another thing that you can do when you try such questions is you can measure using a ruler and get an idea as well, right? If needed, you can measure and get an idea. Right. 23. Figures A, B, C, D, and D show show 4 ways in which a light spring balance can be loaded with a weight of 100 newtons using frictionless pulleys. Okay, the scale readings of the spring balance in the 4 cases would be right. What is the reading of a spring balance? That I have discussed in the last one also. Reading of a spring balance. Reading of a spring balance. 1 second. Okay, reading of a spring balance. Reading of a spring balance is tension on what? Hook. Tension on hook, right? Then simply you need to find the tensions on each hook. That's it, right? So let's say this is T1, say this is T2, say this is T3, right? And in this one, it is at this side, T4, likewise, right? Now, vertical equilibrium here, T1 equals 100, right? T1 equals 100. And if this is T2, we know up to this point, the tension is T2. So again, vertical equilibrium, T2 is also 100. Then along this line, up to here also, that is T2, vertical equilibrium again, 100. And along this line also, T4 up to here, vertical equilibrium again, 100, because both sides are 100, no acceleration here. There is an equilibrium. Then, now if you understood the question at once, nothing to do. But if you didn't get the question, sometimes you might be struggling finding these tensions. Just by using vertical equilibriums, you can do it. All are 100. Answer is 1. See, very easy. Only theory parts you should know is about the reading of a spring balance, that is tension on hook, right? Tension on hook, and then mark tensions and find the resultant. Find the tension using vertical equilibrium, not the resultant. Find the tension using vertical equilibrium. right? Next, 24. Figures A and B show the ways in which the painter could use a system consisting of a platform P, a pulley, and a rope in painting tall buildings. The total weight of the painter and the platform is 400 newtons. Okay, total weight of them is 400 newtons. Then here also it is 400 newtons, right? If the rope is light, then the tension of the rope in two cases are rope is light. Okay. Now in this case, if I mark tensions, see, say T1, T1, same string T1, T1 up to here T1. Now, if we write the vertical equilibrium for this one, vertically upwards forces equals vertically downwards, vertically upwards, we have 2 T1, downwards 400, which means T1 equals 200. 1 is here, T1 equals 200. And for the second scenario, if I mark tensions starting from here, say T2, 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 right? Now, if you consider the vertical equilibrium here of this system, right, only one tension is here, T2 equals 400. Then 200 and 400, 200, 400, 3. Vertical equilibrium. Vertical equilibrium. Right? Not a big deal. Not a big deal. Right? So understanding matters. Understanding matters. Right? Mark the tensions and get the equilibrium. Consider the equilibrium. Mark the tensions and consider the equilibrium. Right? Next. 25. Now again, this is like the previous one. A system of coplanar forces. OA, OB, OC, OD, OE, and OF acts on an object as shown in the figure. Magnitude of OA equals 2OD. Okay, OA. OA is 2OD. Then we can simplify this. Now this OA is this OA. This is 2OD. Then 2OD minus OD is only OD, which means we can have one OD in this particular direction after simplifying with this. After simplifying with this. Right? And OE equals 2OB. OE equals 2OB. Then if this is cancelled off, only half of this remains as OE, because OE is 2OB, 2OB minus OB. Right. Now these two remains. These two remains. Here is this is also only one OB. One OB remains. Here OD remains. Right. Okay. Now the resultant force on the object is most likely to be, resultant force is most likely to be, right? Now we have done with two forces, right? And from the remainings, let's try to find it out. See, now using this, one component comes this way, one component comes this way, right? And from this, one component comes this way, one component comes this way, the other component comes this way, right? Which one is lengthier? The above one, right? Above one. So this is somewhere here, something like this. Okay, then if I focus on the remaining forces, horizontal forces first, right? If I focus on the horizontal forces remaining first, because of OD, this thing remains, right? A force in this particular direction remains. And about the vertical forces, from F, this thing remains. From F, from C also, it remains, right? From C also, it remains. And sorry, by these two method body simplification, see, I didn't see this. Now here we have this one here and this one here to be simplified. So these two are most likely to be cancelled. Most likely to be cancelled. These green color ones are. These ones are going to be cancelled. Most likely to be cancelled because they are equal in size. They are equal in size. Right now, these ones, vertical ones are this one. F remains vertical, and from this component comes downwards. but still this one is greater, so it remains vertically upwards, right? And by C also we know a component is coming, then still it remains vertically upwards. That's all. Yeah, it is vertically upwards, then the reaction is OF. Reaction is OF. Their arguments, we have to compare the sizes of these arrows given. You have to compare the sizes of the arrows given, right? If that is not visible to your naked eye, one last option is measuring using a ruler. But usually you are given the diagram as you can see it, as you can see the magnitudes, compare the magnitudes just by looking at the diagram, right? 26. A thin disk has freedom to rotate around. It should be n axis. N axis passing through its center. Okay, then let's consider center as somewhere here. Oh, passing through its center. The disk is acted upon by 5 coplanar forces 1 to 5, equal in magnitude, as shown in the figure. Consider the following statements made about the torques produced by the forces. Torque. What is torque? Torque is force into perpendicular distance about the point of rotation, right? Force into perpendicular distance about the point of rotation. Force into perpendicular distance about the point of rotation, right? Now, if you need to compare torques, right, connect these perpendicular distances and compare. Since forces are equal, right? Longer the length, higher the torque, right? Longer the length, higher the torque. See, something like this, no? These are the respective lengths. Then it says maximum torque is produced by 2. No, because in 2, this is the perpendicular length, see, a very small one. Then for sure that is not the maximum. Maximum is produced by 1. Right? Maximum is produced by 1 or 3. 3, it's 3. The longest one is 3, no? That is produced by 3. Right? That is produced by 3. Then this is wrong. This one, first one is wrong. Next, rotation of the disk due to resultant torque will be clockwise direction. Maximum torque is by 3. In clockwise direction. Then we have to check all. By 1, there is a clockwise one. By 2, there is also clockwise. Who else? By 3 and 5 anti-clockwise. Right? F is also going to be anti-clockwise. Right? So about rotation of disk. Connect these lines and get an idea about the direction. Connect the lines and get an idea about the direction. Give me 1 second. Okay. This is stuck, no? Right. See, now connect these lines and get an idea about the direction of rotation. Rotation of the disk due to resultant torque will be in clockwise direction. Then by this one, there is one clockwise moment, right? By this one, let me use a different color. By this one, that is clockwise. Right? And this one is more likely to be go through the center. That is more likely to go through the center. So therefore, I'm going to neglect it. Now, if we compare these two, right? Now yet this one is large, no? Which means it can be clockwise. The rotation of the disk due to resultant torque will be clockwise. Yeah. See, when the magnitude of the forces are doubled, the magnitude of the torque will also be doubled. That is also correct because forces are equal. Only distances are different. Now, if you write this torque, F is common, but you will get some distances as D1 plus D2 plus D3, something like this. Now, if this force is doubled, torque will be doubled. That is correct. Right? Then we have an answer B and C. Right? So you should be able to argue now. You'll be able to argue. Connect these perpendicular distances and check on that. Connect these perpendicular distances and check on that. So I think in the past question, the center was printed. So because of a mistake in this copy, the center is not printed. That's why I had to keep the center there. I think in the original past paper, the center is there. Then once the center is there, it is more clear. Otherwise, if we try to locate the center, sometimes it might go wrong. I mean, go wrong in the sense you might not keep the center at the exact center that is supposed to be, right? Get the idea, get the concept of the question. 27. A man of mass 60 kg standing on a uniform wooden rafter hung horizontally by two identical ropes is painting a wall. The mass of rafter is 20 kilograms. Mass of rafter, this is 20 kilograms. Then 200 newtons. Right? What is the minimum tension that should be withheld by each rope so that the man moves safely between A and B? Right. So we know tension will be maximized when the person is at one end of, right? When the person is at this end, let's say. Now, when the man is at this end, this tension will be maximum. Let's say TA and TB will be minimum. And exact opposite happens when he moves to the other side. Exact opposite happens when he moves to the other side. Right? That is how it happens. No? Then I will keep this person, this man, at one end like this and going to do a calculation and get the maximum tension. Right? Then what if I write a force moment about A, considering the equilibrium? Force moment about A. Anti-clockwise is due to TB. Distance is, right, not given, but it is given as uniform. Then let's assume it as L and L. Then TB times 2L. Clockwise is due to 200 times L, right? L to L cancels. Then TB is 100. TB is 100. So we know when this person is here, TB is at its minimum value, right? And TA should be at its maximum value. Now, considering the same equilibrium, if we write a vertical equilibrium, right? TA plus TB equals 600 plus 200. No? Now, TB is known. Then TA plus TB is 100 equals 800. Then TA is 700 newtons, isn't it? TA is 700. TA is 700. Is it clear? TA is 700 newtons. Right? Now, if this string at A can withstand for a tension of 700, right? If this tension at A, if this string at A can withstand for a tension of 700, it won't break. It won't break. Right? Now, if this person moves to the other side, right, that thing happens, the vice versa, and B becomes 700. Now, the question is, minimum tension that should be withheld by each rope so that man is safe, right? Then it should be 700. It should be 700, not 100. It should be 700, right? Because otherwise, when the person is at one end, it falls, it breaks, right? If that is 700 to be the maximum value, that should be the minimum value of the tension. The string should withstand. Got it? Right? 100 නෙමෙයි answer එක. This is the minimum one. Right? 729. A bull fastened to a strong tree with a rope attempting to eat a nearby coconut plant is shown in the figure A. The free body diagram for the bull is correctly represented by, okay, free body diagram for the bull. Right, now bull is trying to, one second, I'm getting a call. Right. See, now bull is trying to pull this in this direction. Then we know if I mark tension on string. See, if I mark tension on string, right? Tensions on string are like this. These are the tensions on string, right? Using red, I'll be marking tensions on string, and using blue, I'll be marking tensions on bull, right? Now, if the tension on string is to this direction, what is asked? The free body diagram for the bull is correctly represented by. Okay, free body diagram for the bull. Sorry, red belly mama color the bull, ne? See? So, using red, I'll be marking the forces acting on bull, and using blue, I'll be marking the forces acting on a string, right? Now, these are on bull. If you are asked about the string, they are opposite. Right? Now, one force is identified. And what else? What else to be marked? Frictions are marked and weight is marked. So, we know anyway, weight is acting downwards from its center of gravity, right? So, its center of gravity will be somewhere in the tummy, right? And when this bull is trying to pull this forward, what about the direction of friction? Now he is trying to pull this forward. Then moving tendency is backwards from the string. When moving tendency is backwards, friction is again forward. Then friction on both legs will be forward. Right? Friction on both legs will be forward. Then what's matching? Tension is marked. Now these are the forces. No? These are the forces. These are the forces on bull, right? These are the forces. Then tension is marked. 4 is there. Frictions are marked, right? It's only 4, right? And reactions are also there. There are 2 reactions like this as well, right? 4, you know, that's in 4. Reactions are also marked. Right? Then it's 4. No center of circle printed on past paper question 26. No, it should be there in Pesuru, that is not printed. In the original paper, it should be there, not in Pesuru. Pesuru, it is not printed. It's a mistake. Right? Okay, then these are the reactions. These 2 are the reaction forces acting on bull. Reactions. These 2 are reactions. These 2 are frictions. Right? This is weight and this is tension. So answer 4. Answer 4. Right. 30. The pulley arrangement shown in the figure exerts a force on a leg of a patient connected to a traction device D. The pulleys are frictionless and the system is at equilibrium. If the horizontal force acting on the leg by D is 80 newtons, then the value of hanging mass M will be cos 30 is given. Okay. Now, these are force equilibrium question. No? Then mark all forces before considering an equilibrium. Mark all forces. This is mg, right? And if I mark this tension as T, this is the same string, then you can mark T like this up to this point. And another data is given as horizontal force acting on the leg by D. Leg by D is 80. On the leg by D. Then on the leg by D, that force has to be like this, no? That is given as 80. Right? Mark karu. See, now if needed, you can mark both sides. It should be something like this. On the leg by D, this one. This is given as 80. This is given as, see, given as 80. Given as this one. Given as 80. Right. Now, what I'm trying to do is going to write an equilibrium considering this. This one. Right? Let's consider horizontal equilibrium. Considering horizontal equilibrium. right? Horizontally rightwards forces equals horizontally leftward forces. Horizontally rightwards, we have two components coming from T towards the angle that is cos component, so that is T cos theta, and altogether is 2T cos theta, 2T cos theta. Leftwards, that is only this force 80. Leftwards, that is only 80, right? Then simplify this. 40 equals T cos 30. Ne? Wait. Cos 30. This is cos 30, right? So that is root 3 over 2. Simplify T. So it comes T as 80 over root 3. T as 80 over root 3, right? What is asked? M. Now from this vertical equilibrium we know, this is also vertical equilibrium, no? From that vertical equilibrium you know this. From that vertical equilibrium you know T equals mg, right? T is 80 over root 3 mg. So m remains, m is 8 over root 3, right? 8 over root 3. Answer 3. See, a simple calculation from equilibrium. Right? Consider equilibrium properly. Consider the equilibrium. Right? Let's move on. 31. 31. In the figure shown, F1, F2, and F3 represent fixed vectors of three forces acting at the point O. In the XT plane, F4 is a vector representing a rotating force about the point O. In the same XY plane, rotating one. Okay. Which of the following best represents the direction of the resultant vector? When the vector F4 is at angles 0, 90, and 180. Right. 0, 90, and 180. Okay, now grid is given. When the grid is given, we can easily count the grid and get an idea about their magnitudes. That's why the grid is given. Right? We can simply count the grid. We can simply count the grids and get an idea. Now, as an example, if you need to get an idea about this force, this is like 2 grids. This is also like 2 grids, right? This is like 3 grids. This is like 1.5. So likewise, we can get an idea now. That's why. Okay, now let's see. When this is 0. So when this is 0, what happens is this force should be like this, no? The force should be like this when it is 0. Now, if we simplify these two, when it is 0, right? Initially, when it is at 0, right? Now, if you simplify, see what happens. Now, this is for like 1.5 grids, and this is for 2 grids. This is for 1.5 grids. No? This one is for 1.5 grids. This is for 2 grids. Then the resultant remains in this direction. And from this upwards one, there is around 2 grids, right? There is around 2 grids. And this one is more than 2. Then resultant remains downwards, isn't it? Then resultant of these two should act in between. Resultant of these two should act in between like this, right? Then for the first one, these three answers are matching. These three directions are matching, right? In that direction. Then go to 90. Second scenario at 90. At 90. At 90 means this one is like this. This one is like this now. F4. F4 is at 90, right? That is like this. Then upwards, we have 2 grids from this and 1.5 from this. That is 3.5. For sure, that is going to be greater than this. That is going to be greater than this. Then an upward one remains. An upward one remains, isn't it? Right? And from here, now only this one remains, which means that is acting in this particular direction. Resultant is going to be in between these two, something like this. Resultant is going to be in between these two, something like this. Then what are the matching directions we have? Then it's there, right? Only two. Only two. Even without checking the third one. Answer is 2. Right? No need to check the third one. That's here. Right? See? Not a big deal. Not a big deal. Right. Since we discussed like 10, 11 questions, any questions so far from the things we discussed? Is there anything from the questions we discussed so far? All good? Or anything? Okay, it seems no any questions. We'll move on. Twenty-six runs. You are like 26 weeks end of the exam now, right? 26 weeks and 2 days end of the exam now. Exactly 26 weeks and 2 days. Exactly 26 weeks and 2 days now. Friday is also gone. No, Friday is also gone. Right. So without Friday, that is exactly 26 weeks and right 26 weeks and 2 days. 26 weeks and 2 days. Right. So time flies. Time flies around 180 days. Around 180 days. Around 180 days. Right. Something like that. Time flies. Right. All questions are right. 32. A, B, C, D, and E are five coplanar forces of equal magnitudes acting on a body as shown in figure A. Right. This is figure A. Which of the following diagrams best represents the direction of the resultant of these forces? Direction of the resultant of these forces. Right. Now, see, there are parallel ones, no? Right. Let's go ahead with the parallel ones. See, A is parallel to B and both are parallel to E. Now, if we simplify AB, they are equal magnitudes acting along equal magnitudes. Okay. Then if they are equal magnitudes, right? If they are equal magnitudes, it is like 2F is acting along this direction and only 1F is acting along this direction. Then resultant is going to be F acting along this direction. Equal magnitudes, no? Right? This is like F and F and F. Right? 2F along this direction, only 1F along this direction. The resultant will be 1F remains in this particular direction. That is done. And if we simplify these two now, this is also parallel to this one, F and F. Right? So it's like 2F acts. Right? It's like 2F1. It's like 2F acts in that particular direction. Right? 2F. It is like 2F acts in that particular direction. It is like 2F acts in that particular direction. Right? Then this is the higher force. Always resultant will be closer to the higher force. Higher force is this, no? Then resultant will be closer to this one. So it is going to act somewhere like this. Right? Only one answer is given in that kind of a direction, that is 4. See how easy it is if you understood the questions properly. Right? 32. A simple one. 32 is a simple one. 2018. Right? Simple. 33. A uniform straight heavy plank of length 5L. Then if there is 5L, this should also be 2L. Right. And mass 5M is kept. Mass 5M, then it acts somewhere here. 5 mg. Right. If this is 2, right. If this is 2, we know this is only L over 2 here. That is only L over 2 here. L over 2 here. Right. Identify distances. Horizontal on two supports separated by a distance 2L. As shown in the figure, a painter of mass M needs to walk along the entire length of the plank carrying his bucket of paint. What is the maximum mass of the bucket of paint that can be carried by the painter without toppling the plank? Right. So, first, there are few decisions to you to make. Right. There are few decisions to you to make. Right. One decision is you have to decide around which point it has a higher possibility of toppling. Right? Toppling is decided by force moments, no? Right? Toppling. Toppling is decided by force moments. Is decided by force moments. Right? So we know force moments are F times D. F times D. Now when this person moves here and there, right? His weight is same. Weight is same, right? Then higher the distance, higher the force moment, higher the ability of toppling. Higher the distance, higher the force moment, higher the ability, higher the possibility of toppling. Higher the possibility of toppling. Right? Now, from this side there is only 1L, but for this side there is 2L, which means the highest risk Highest risk of falling is when the person is here. The highest risk of falling is when the person is here. If this thing is not going to fall, even if this person is at this end, which means for all other points it is never going to fall, right? If it is not going to fall when the person is at the highest distance, right? Furthest distance away from the wedge, right? Furthest distance away, if he is safe, which means for all other points the person is safe. That's the logic, right? මේ point එකටත් වැටෙන්නේ නැත්නම් ආයෙ මෙයා වැටෙන්නේ නැහැ කොහොමද? හරි? That's the logic. Okay. Now considering that, let's consider force moments about this point. Let's say this point O. Then force moments about point O should be equal. Force moments about point O should be equal. Now mass of the person is given as simple m, no? Is it simple m? Where is it? Point of mass m, yeah, simple m. So let's assume mass of the bucket as capital M. Then this can be marked as simple m plus capital M g. Okay. Now about point O. Anticlockwise force moment is due to 5 mg. 5 mg. Perpendicular distance is L over 2. Right? Clockwise force moment is due to m plus mg. M plus mg. Distance is 2L. I have to simplify this. Right? No need to worry about this reaction. No need to worry about this reaction because when it is satisfying the requirement of top plane, the rod slightly starts to lift from that wedge, lift from the knife edge, right? So therefore it becomes 0. It becomes 0 at the point of top plane, right? Then G to G cancels and L to L cancels. Simplify. This is 5m over 2 equals this side 2m plus 2 capital M, right? 5m over 2 minus 2m is m over 2, no? Then m over 2 equals 2 capital M. So capital M equals simple m over 4. Then maximum mass of the basket is m over 4. Again, a simple calculation based on equilibrium, right? Take down if anything. Take down if anything. You can get all updates about the next question discussion through the channels, right? Sometimes I'll be taking surface tension, or sometimes viscosity, or some part in thermal, something like that is probable, or otherwise center of gravity, right? Let's see. We'll do something good. Right, let's go on. 34. Two teams start to play tug of war using a rope of uniform strength on a hard, flat, horizontal surface as shown in the figure. Both teams apply equal forces, and as a result, the point O, this one, point O on the rope does not move. Consider the following statements made about the situation. If each of the member of two groups applies the same force on the rope, the magnitude of the tension throughout the rope is same. It is like this. Now, if I take it to somewhere here, let's say point O is this, right? Now, each one applies a T like this, a tension like this, right? Each one applies a tension like this. Let's say each one applies a tension like this, right? Now, what happens is, now if you think of the string, think of the rope part by part. If you think of the rope part by part, right? If you consider this part, right? All the tensions act. But if you consider a part like this, see, only one less tension acts. Here, two less tensions act, three less tensions act. So, which means part by part, total force changes. When total force changes, tension changes. So, that is not going to same throughout. That changes, right? That is not going to same throughout. That changes. So, therefore, that is wrong. It changes. B. If the magnitude of the tension on rope exceeds its breaking tension, the rope will break only at point between P and Q. Where is P and Q? Okay. P is somewhere here. Q is somewhere here. It is correct. The reason is maximum tension throughout the rope acts on this region. No? Maximum tension throughout the rope acts on this region. Why? The same reason I explained here. All the tensions, all the all the weight, all the force on the tensions are acting on this region from all of them. See, from all of them. Then maximum tensions are always between P and Q. Then maximum possibility, the highest possibility of breaking the string is from a point between P and Q. That is correct, right? Because of the higher force. See, the magnitude of the maximum force that can be applied by an individual on the rope depends on the coefficient of static friction. On the coefficient of static friction between feet of the individual and the surface. Correct, no? Because if the friction is not enough, right, the force that they can apply is also less, because they are going to slip. They are going to slip, right? The magnitude of the maximum force that can be applied, yeah. Because with the limiting friction, higher the limiting friction, they can apply a force, apply a tension that is equal to limiting friction without being moved. What's the point? So it depends on limiting friction. Right? Maximum force that can be applied by an individual depends on the coefficient of static friction. Coefficient of static friction and limiting friction. Right? That's correct. Higher the coefficient of friction, higher limiting friction, then higher force can be applied, because they can stay still without sliding if the friction is enough. If the friction is enough. So C is correct. Then only B and C. Only B and C. Right? A good argument. Right? A good argument. Next. 35. The magnitudes of two coplanar forces acting on a body are 11 newtons and 5 newtons. Coplanar forces acting on a body, 11 newtons and 5 newtons. 11 and 5. Which one of the following values could not be equal, could not be equal to the magnitude of the resultant force? Right. Now, when two forces are given, right, 2 or 3 or likewise, when multiple forces are given, if you need to find the minimum value and the maximum value, minimum and the maximum, right? Minimum value is always when these two forces act opposite to each other, right? Minimum is always when these two act opposite to each other like this. Then minimum is 11 minus 5, 6 newtons. Minimum force is going to be 6 newtons, right? And maximum is always when these two act to the same direction like this. Then it is 11 plus 5, 16 newtons, right? Any value in between, see, any value in between 6 and 16, any value in between 6 and 16 is gettable, right? When these angles changes, like 11 to 5, when this angle changes from here to here to here to here, likewise, any value in between this range, 16 to 6, any value in the range is gettable. Any value is gettable, right? Then if there is a value which is out of this range, that couldn't be taken, right? 16 is possible, 9 is possible, 7 is possible, 6 is possible, but not 5. 5 is not possible, right? So answer is 5. That's also a good one, right? Keep that in mind. Even though you are given like 3-4 forces, you can use the same logic, right? Even though you are given like 3-4 forces, we can use the same logic, right? Same logic can be used. Okay, so today we had only 15 questions because I wanted to finish off vectors and equilibrium, right? Right. Yeah, we have come to the end of the discussion for today. What about the questions? Anything to clarify? Any doubts? Is there anything? What about the questions we discussed? Is there anything? Is there anything? Or is it all good? Right. So if no questions, we can wind up. Today it's a little bit early compared to other days, right? Because today we had only 15 questions, 15 or 16, 16. We had only 16 questions. That's why. Right. So about next SQA discussion, you can get all updates through the channels. I'll decide on which topic I'm going to take the discussion of, and we'll let you know. Right. We'll decide about which which topic we are going to take, and we'll let you know. Right? Totally fine. Okay, good. All right. And since surface tension and viscosity is also finished in the ongoing reverse class, right? Sometimes I might be, right? I might be giving some priority to that as well, right? And then in the next week, we'll be doing center of gravity, right? We'll do something like that. Let's see, right? So you can get all the updates anyway through the channels, right? And reminding again, 26 runs, you are only 26 weeks ahead, right? Only 26, just 26 weeks ahead, around 180 days to the exam, right? So don't waste even a minute of time that you have in your life these days, because it is going to change your whole life, right? This time in your life is going to change your whole life, right? That's the thing. Very much critical and crucial, right? So what do you do? What you do, right? What you do will be coming in return as a result, right? What you do now will be coming in return as a result, right? That's how it happens always, right? So what you harvest will be coming in return, will be what you plant will be coming as harvest, coming in return, right? What you plant will coming as result, no? Right? Okay. Yeah, we got 26 weeks, so that's why the still discussions are started, because we have like quite a good time. I mean, good enough time for the past paper discussions, right? That's why. So get the maximum out of this. That's a benefit. Otherwise, now I also ended finished the last class. I mean, today the last class I had around 6:45 7, right? 6:45 7, 6:45 around, right? And when I came home after finishing everything, it was like 7:15, 7:30, and then again I had to start your discussion at 8. So I adjusted myself and started. So likewise, now we have to do sacrifices, right? We have to do sacrifices, and I hope you will be getting the maximum out of this, right? Because when both of our efforts met each other, only you are going to get the maximum out of this, maximum result from this, right? When both met each other, like effort from my side in classes and discussions and everything, and effort from your side. Once these two met each other, right, the result will be a good one, good in the sense, a better one, right? Okay, then since we have come to the end of the discussion, I'm going to wind up. Is there anything that you need to know? Since I finished the class a little bit early, I'm asking, is there anything that you need to know from my side? Anything? Anything you wanted to ask, you wanted to know? Right. Okay, it seems nothing, no? Right. Then there's nothing. If there's nothing, let's wind up. Okay, then study hard and stay safe, right? And see you again in a next discussion, next S2A, right? Good night and goodbye. Ending the meeting, right? Goodbye.